Welcome all. Welcome to this lecture of object-oriented programming. And today we'll be continuing with Unit 3 and we'll see some examples, practical examples of using arrays. Okay. So let me go ahead. Let me show the disclaimer, then I'll start the session. Okay. So we have seen various things like, defining and calling method and, using methods to check various things, right? We have seen various things like this. And we have also, recently we saw how to use arrays, how to copy arrays, right? And how to use the array copy method and all those things. So let's try to make use of an array copy method. Okay. And let's see how this passing array to method and all these things work. So last time we had seen an example of this particular class, that is array example 2, where basically what do we do is we simply use the for each loop to print the array, and also we use the simple for loop to print that array. And then we had also seen an example of how to reverse an array, right? How to reverse a particular array by first we display the source array, right? Then we send it to reverse method, and then we print it out. So I had told you people to do this, right? To do this reverse part. So has anyone of you completed this part, array reverse example 01? Yes. Has one of you done it? Please let me know. Yes. Has anyone of you done this, have completed the implementation of this reverse method? Please let me know. And if you have given me a pull request for that, then I will accept that pull request and I will merge it with this particular program. If yes, please do let me know. Okay, no problem. Okay, so let's see how basically we can reverse an array, right? So in this, let me see whether we have the code for that. No, we have to manually do it. And in this slide, I think we had seen how to reverse an array, right? Okay, so this was the, okay, so this is the, see, this is the way, this is returning an array from a method. This is what we saw, and we had to implement this method. Okay. So now what I'll do is I'll start making this particular method. Okay. And let me start with this reverse method. We had seen this example last time. I'd given it to you people so that you can complete it, but now it's okay. I will show it to you how to do that. Okay. Here what happens is we have this array. Here we are displaying it out. We are sending that array to this reverse method, and that reverse method accepts it into a list variable, and then what we'll do is we'll reverse it out. So for this, what we'll do is we'll say int reverse list is equal to new int, and in brackets what we'll do is here we'll use this list to define its length, because we want a same length array. right? So we give the length of the list in order to create the reverse list. Okay, and in the end we will be returning it out. Okay, and what we will do is according to this particular method, we'll be using a for loop. Okay, and which will start from 0 to j is equal to results length minus 1. Okay, so sorry, not from to that, it will start from 0, j I would be equal to 0 and j would be equal to the result length. So I would be pointing over here and j would be pointing over here, and it would go up to I less than list dot length, and I would be incremented and j would be decremented, right? This would happen. So let me write it over here. Let me call this as result, and we'll be returning the result part. And now here I'm using for loop for int I equal to 0 and j. So you can write multiple statements in the same single section of for loop by separating them by comma. Okay, so I say for int I equal to 0 and j is equal to this is list dot length. We'll say length dot length minus 1. Okay, and the second part of the for loop, so this is the first part of the for loop where initialization happens. Okay, second part of the for loop is the condition. What would be the condition? Condition would be that I should be less than list dot length. So I should be less than list dot length. Okay, and then we increment I and also decrement j. So see, in for loop, okay, these are the two sections where you can use multiple statements. Which are these two? This one, the initialization part. Here you can use two statements or more than one statement by separating them by comma. And the second part is increment decrement part. Here also you can use multiple statements by separating them by comma. But in this section, in the condition section, you cannot use, in this condition section, you cannot use what? Multiple statements. If you want to use multiple statements, it means you are using multiple conditions. And if you want to combine multiple conditions, then you will have to make use of relational operators like and, or, and those things. So that's why please remember this thing, that this part of for loop can have multiple statements separated by comma. This third part of the for loop can also have multiple statements separated by comma. But the middle part, which is condition, cannot have multiple statements separated by comma. It can have multiple conditions separated by relational operators. Okay. So here, in this for loop, what we will do is we will be reversing whatever is there in jth location of the list will be given to the ith location of result. So result of I is equal to list of what? List of j. That's it. This much only is needed. That's it. And well, you can even you can do it like this. Actually, it's the result of j is equal to list of I. So it will begin from starting of list and it will give it to the ending of result in that way result, or you can even do vice versa. Okay, so this the array has been reversed. Now let me run it out. If I run this, you'll get to see that okay, so this is the array, this is the source array, and after reversing, this is set. Okay, 10 5 1 3 2. You can see it has been reversed, right? And let me again add some more values to it. Okay, maybe 4 and 7 and 6. Okay, so Let us run this again. And there it is. You can see this is the original array. It has been reversed. 6, 7, 4, 10, 5, 1, 3, 2. You can see that? Yes. So this is how it reverses the array. What does it do? We have declared an array and initialize it with some values. We display it before reversing the original array. Then we send that array to the reverse method. Reverse method declares a new result array with the same length of that of list. It traverses from 0 to then the for loop, it traverses from 0 up to the length of the list, and also initializes one more index that starts from the end of the list. Okay, so I will get incremented, j will get decremented after each iteration of the loop, and then we assign the last element of the result as the first element of list. So in that way, this j goes on decrementing, I goes on incrementing, and thus the result has got a reversed list, and then we return it out. And then it is assigned this source array is this when this reverse method returns something, it returns a reverse list. So the same source array has been is overwriting. So this reference points to now new array, and the old array is lost, and now we have the new array which is been reversed. Okay. If you don't want to lose the old array, then you can simply use a new variable instead of the source array. You can create a new variable. Okay. So that is a reverse example. Now let us see some more example specifically of variable length argument list. So see, this is how we can use variable length argument list. Okay, let me create a new array example saying array variable length argument list dot java. Here in this main method, what we will do is we will typically get, instead of doing this, we can get the numbers from the user. Okay, so we will say we'll use the scanner class, scanner input is equal to new scanner system.n, and here we will say what we'll do is we'll use this system.out.println and say enter how many numbers you want to enter. Okay, that will ask the user. What we'll do, we'll ask the user, right? And here we will say int n is equal to input dot next int, right? So we get one integer from the user. Now we'll run the for loop, and we'll say int I equal to 0 and I is less than n and I plus plus. And in this loop, what we'll do is we'll read out that particular number. So again, we'll use this system.out.print statement. Okay, over here, and here we'll say enter a number. Okay, and it will read it into what? Into an array. Okay, it will read it into an array. Okay, so let's first declare an array saying int arr equal to new int how much size we need, up to n size. Okay, and then it will read that out, okay, by saying arr of I is equal to input dot next int. You see that? So we'll be reading the number from the user one by one, And once we have read the array, what we will do is we will send it to the this kind of method called as print max, or simply let's call it as max. And let's here we'll be passing this array and it's max, but it will obviously return a maximum value, so we'll print it out. So it's a system dot out dot println, and the maximum number out number is this. We concat it with maximum of array. Now we have to define this max method. So we say there's a public, it's static, it returns an integer, and the name is max. It takes an array called arr. Okay. Now what we'll do is we'll simply use this logic to check whether a number is greater than all of the numbers. So here we simply define int result is equal to ARR of 0. Okay, we get the first what? We get the first value directly. Okay, and that value is given to this result. Okay, and then now we'll be using a for loop saying for int I equal to z, I equal to, will start from 1, not from 0 now, and we say I should be less than ARR dot length and I plus plus, and here in this loop we will compare it saying with say if result is greater than ARR of I, means the first element that we gave to this result, if that first number is greater than the next upcoming numbers in the array, then you do what? Then you simply assign that number to result, saying result is equal to ARR of I. So you assign the maximum value to result. Okay. And in the end, you will say what? You will return the result. So you will say return result. That's it. So this returns an integer number. You check this out. What happens over here? In this, what happens is we basically ask the user how many numbers you want to enter. User enters a number. For that many numbers, we create an array. Then we read the numbers from the user saying enter a number. Each time user enters the number, we put it in the ith location of this array. So we populate the array, and then we pass that array to this max method, where basically we start with the 0th element of the array, and in the for loop we start comparing it with the next element, and we check if that result is, that is the first element, is greater than the next element, then assign the next element to result, and then increment I. So you try to compare it with all the elements of the array up to the array length. Okay, and in the end, whatever you have inside this result is nothing but the maximum value, so you return that out. Okay, so let me just run it out. So what it will do is it will ask the user what you want to, how many numbers you want to enter. I'll say 5 numbers. It says I'll enter a number. I say 6, then 9, then 3, and 8, and 2. Okay, so the maximum number is 2. So it has taken reverse way, it has taken a minimum. It has given us the minimum number, not the maximum number. Let me just change the condition. The condition here should be if result is less than ARR. Okay. If result is less than ARR of I, then you assign the result the new value of ARR of I. Okay. So let me run it again. Okay, how many numbers you want to enter? We say 5. And it asks for us for numbers. We enter the number. And there it is. The maximum number is 11. You see that? We can even again run it out. Okay, we again run it out. It asks how many numbers. Let's say 8 numbers. And there it is. It gives us the maximum number. You see that? Right? So we say 8 numbers. So it runs the loop 8 times and reads 8 numbers from us, populates the array, and then it searches inside the array, which is the maximum number. You see? So this is how it works. Okay, this is variable length argument list. Now, here we don't know how much length of this array will come, right? So that's why we, instead of this dot dot, instead of this, we can even say dot dot dot. That is also possible. If I run this, that works perfectly well. Within 4, you see, it has run perfectly well. So basically, you put here integer array or this triple dots, both are same. Understand? And I can even give it like this now. See, if it would have been an array, then it would not have been possible for me to use this thing. Check this out. If I want to say something like this, the maximum number out of, let's say max, we call max, and then we pass something 44, 55, and 66. If we pass something like this, then this won't work. This will give you error. This gives you error, right? What you can see, it's an error. So now this will not run at all. So if I convert this array into this dot dot dot, a variable length argument list, then that error will go away. You can see that error has gone away after this max. So both of this will run properly well. Both of this will run properly well, right? Let me run it out. I run this and it asks, I enter 3 numbers. Which is maximum number is 5, and that second list, out of the second list, maximum number is 66. Yes, you can see out of the second list, maximum number is 66, right? So now we can understand what is the use of this 3 dots. It says that this max may receive a variable length argument list. So either that can be a list of numbers like this, which will be converted into an what? Which will be converted into an int array, and then it will be given over here. Okay, or it itself is an array, so that it can be directly given over here. Understand what does it mean? Yes, there is a difference between accepting an array and accepting a variable length argument list. In the end, the output of this will be what? The output of this will be an integer array. If you are sending an integer array, then there is no need to convert it. It directly gives you an integer array. But if you are sending an integer list, list of numbers, then it will convert that particular list of numbers into an integer array. And then the control will process into this max method. Okay. So understand the difference between, if I use this brackets over here instead of dots, then this would give you error. It would generate the error. Okay. And if I, instead of, I don't know what, if I don't know, I'm in a situation where I don't know what number of arguments are going to come into a particular method. In that situation, I use 3 dots, variable length argument list. This is called as variable length argument list. Okay. So this is the second program. Now let me show you one more program related to the arrays. So we'll see how we can use arrays. Okay. Searching, I think we have done. We can use this binary search part, right? We can use this binary search part. Let me for this binary search part. And for that, what we'll do is we'll typically read the input from the user. Okay, so let me just take this and make a class called array binary search, and here we'll just simply paste this main method, and inside this let's take int only. Okay, so here we have this see how many numbers you want to enter. That much, for that much numbers the array is created, and then we read the number from the user. Okay, and once we have populated there, and now what we have to do is we have to search a particular number now. So we will ask the user for searching a number. So what we will say is enter a key, a number, or a key to search in the array. Enter a key to search in the array. So this will do what? This will read a number. So key, let's say int key is equal to input dot next int. So we'll read that next integer as a key from the user. Okay, and now we will have to run the for loop, right? So, or we can even say directly call this binary search method. So let's give the name of the method as binary search, and inside that binary search we will pass this array. Okay. And here we will define this binary search method. So this will be public static, okay, and it will return the key, right? So we'll say int binary search int list. So this is an array list. Okay, this is an array, integer array. So this ARR is nothing but an integer array which is passed to this binary search, and it will return, let's say right now we return -1, so that error goes away. Okay, and this binary search will return result. So we'll say int result, or we say index. Index is equal to binary search. So now this index is to be used. We say if index is equal to -1, it means that the key was not found. So we'll simply say that the key, what is the key? Let's concat it. Key is basically the key variable, key value is the key variable, and was not found in the array. That is our message that we gave, that the key was not found in the array, right? Else we can say that this here we can say the key was found on location, which location? Index location. Okay, so see, this is the key that we got from the user. We pass the array. Okay, we have to pass the key also. Forgot that we have to pass the key also. This binary search will get the list, that is array, and also the key. Okay, and it searches for the key inside this list. and it returns an index. If that index is minus 1, then we said that key was not found in the array. Else we said the key was found on the location, this particular location of index. Okay. And we can first, here also we can say equal to -1. First we assign index to -1, also we assign -1 to index, and here then we say index is equal to binary search. So if at all binary search fails, then at least we have -1. Okay, but right now let's keep it in a single line. This is much better. So index is equal to the result of binary search. Now that result can be -1 or the index itself. So how do we find the index? Yes, we find the index with this particular formula. Okay, so we declare low, high, both. Let's start with declaring low and high. So we say int low is equal to 0 and high is equal to list dot length -1. Okay, so the last element is high and the 0th element is low. Then we say that while high is greater than low, we start with while high should be greater than low. This should be the terminating condition, and since up to that condition, what we have to do is we first declare mid as low plus high divided by 2. So each time in each iteration, mid will be declared as a new element and it will have new value of low plus high divided by 2. That is mid. Okay. Once you have got the mid, now what you will do is you will specifically check. We will check it with if key is less than the what? Key is less than the list of mid. We compare it with the mid value, right? And if that is the case, then you go into the first half of the array, right? Otherwise, you go into the next half. So here what we do is check this out. If key is less than list of mid, then you bring the high to mid -1. Okay. So we simply say here high is equal to mid -1. Okay. Then we again say else. If that is not the case, then we again have a condition. If key is equal to the list of mid, if that's the case, then what do we do is then we simply return the mid. That is, the mid is to be returned. Why mid is to be returned? Because that is the mid is the index on which we found the key. Otherwise we put low as mid +1. Otherwise we put else we put what? Else we put low is equal to mid +1. So we bring the low further. Okay. So if this is the case, then we start searching in the first half by making the high as 1 less than mid. Else we compare if it is equal to mid, then we return the mid, the index itself. Otherwise, we have to bring the low ahead and we start searching in the next half of the array. Okay. And then, so in the end, this returns -1. Otherwise, at least if it matches, then it returns mid at some point. Okay. So let me now run this with, let's see whether we get a proper output or not. How many numbers you want to enter? We said 5 numbers, 11, 22, 50, 33, 44, 55. So we need a sorted array. So I will enter a sorted array only. Okay. Now I say which key you want to search in for. I'll set 22. And that's it. It says, okay, the key was not found in the array. Okay, so there is some issue in our logic. Okay. Mm, okay. Let's try to have a bigger array and let's check whether that works or not. We say 8 arrays and the number is 11, 22, 33, 44, 55, 66, 77, 88. And we want to search is number 44. Where it is found. The key 44 was found on location 3. Okay. So did we do some mistake in entering this number? Is it so? Okay. It says that is not found in the array. Okay. Mm, so what issue I found over here is that maybe the number of you know the array elements needs to be even. So let's try that. Let's again run this and let's check with 6 elements. 22, 33, 44, 45, 66, and 77. Now we want to search is 66. And that's it. It was found on location number 4. You can see 0, 1, 2, 3, 4. That's it. It is correct. So it works well with even number of uh, input if it is been given. Okay, it works very well with that. If we use an odd number, let's see, let's use an odd number, let's use as 9. This is an older program. Let's run this again. Let's see whether that goes ahead with 9 numbers or not. Enter number 11, 22. Now here we want to search as 88. Okay, so it has been found perfectly well. It's running perfectly well. Okay, I think so. We might not have entered the numbers properly in the previously. Otherwise, it would have run. And see here also, it runs with the odd numbers also and with even numbers also. It was 88 was found on location 7. Right. If you again run this and we use the same data, 11, 22, 33, 24, 55, 66, 77, 88, 99, and we now say we want to find 22, it finds perfectly well. You see, it says 0 and 1. So location is number 1. Okay. So that's the index. So I think that's it. This binary search is complete. Our binary search is working perfectly well. Okay. Now what we have to do is we have to search. We have to we have to do. Uh, uh, we can use the sort method, but I leave it to you people to work onto it. You can use the sort method. So what I would suggest you is once the user enters array, you sort it out and then you go give it for searching. Okay, so you can use this arrays.sort method. It is available in java.util, right? So we'll have to let's import all the process. So now here we can use arrays.sort. Okay, so we can simply say arrays.sort. This will do what? This will sort that particular array ARR. Okay, and now let's see whether this sorting thing works or not. So in this we enter 9. We enter it in the reverse manner. 9 9. And now we want to find the key search in the array is number, let's say 22, and there it is. It has been found on location 1. Why? Because this array was sorted by arrays.sort. Okay, and then we got the location. We can even print that array. You can even print that array specifically. Okay, using the same kind of for loop, we can print it afterwards. Okay, and we can simply say array elements are right, and here we'll simply do what? Instead of displaying it out, we'll simply print it out. System dot out dot print, and print it with some space. Okay, this will basically do what? This will this will basically print the array. Okay, saying that the elements are these, and then you ask for a search key. Okay, or we can even put this afterwards over here. Let's run this. Again says we say 9. So we are entering in a reverse manner. You can see it will get sorted out, and then it will, we say number is 22. There it is. See, this is the array, and the key 20 was found on location 1. You see that? That's it. So that's it. This is the sorted array that we get from arrays.sort, and this is the answer that we get. Okay. Okay. So that's about binary search. Now we have also seen sorting. You can try out other methods also. Okay. And now let's see two-dimensional arrays. In two-dimensional arrays, we can populate an two-dimensional array, and we can try it out. Let me use some other slide, and from that, here it is. Here we will be using two-dimensional arrays. Okay, let's try to process a two-dimensional array. Okay, let me say new file. I'll create a new file. Okay, array, and this is two-dimension 01.java. Okay, and inside this main, what we'll do is we'll get the numbers from user first. Let's do that. So for that, what we'll do is, for that we'll say, okay, not how many numbers we want to enter. Let's declare on our own int we'll say list is equal to new int, and how much size shall we prefer? Let's take 5 by 5. So 5 and 5. Okay, and for each, let's say 5 by 2. Let's say it will be 5 to 10. Okay, and we'll have to run loop 2 times. So for int I is equal to j, so I equal to 0, I less than list dot length. Okay, and inside this again we use for loop for int j equal to 0, j is less than what? List of I dot length. Okay, and we'll increment j plus plus, and we'll simply here say, instead of each time asking, okay, we can ask each time, and list of I and j is equal to input dot next. So this will do what? This will read a next input from user and it will put into the I and j location of list. So once this is populating of array from by reading it from user, and what we can do is we can then we can specifically display it out. Okay, we can display it out. So let's instead of any other thing, let's display it out simply. So for displaying also we need two for loops. Yep. Okay. So here instead of printing this thing, what we'll print is we'll print this AR list of ij concatenated with a space, and after each for loop ends, after each for loop ends, so this for loop ends over here. This inner for loop ends over here. So after each for loop ends, we'll have to print a new line. Okay, remember we are using system.out.print, but here we will use print ln. A new line will be printed. Okay, that's it. So let's matrix is this will print and then it will be printed like this. Okay. So let's now, okay, now the thing is here in this inner for loop we have to put the curly braces because there are more than one statements. So we need a curly brace over here. So now it is complete. Okay, perfectly well. Let's run this part. This is a number, enter a number, right? So we have to enter 10 numbers. So I'll start with 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And you can see 5 by 2 matrix has been displayed over here. You see that? This is a 5 by 2 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see that? So that's perfectly well. Okay. That is two-dimensional arrays. Okay, this is how we process two-dimensional arrays. See, we need two for loops in order to read their values, and also similarly we need two for loops to display those values. And while displaying, we have to make sure that once an array or one row gets displayed, we have to print a new line. You see that? Okay. So that's it. That's it for the day. Let's close the chapter over here, and if at all in doubt you can ask me. Okay, we will have that interaction.